we talked about logarithms last Monday, right? Now, I feel like logarithms are really scary to some people just because like we don't really see logarithms that often in real life, right? I mean, we see a lot of exponents, see a lot of that stuff, but logarithms, we just don't really talk about them. They are very important though. They have lots of different applications. So it is a useful thing to know. And well, I guess it's useful to know in this class because it'll be on the final. So we talked about logarithms. We talked about how to find logarithms, like how to mathematically calculate what the number is. We also talked about logarithm properties where, like, for example, if you see a log and an exponent, they cancel each other out. So we talked about how to do that. We talked about special logs, like the log of 1 is always 0, all of that fun stuff. And I think the only thing we have left in this set of notes is figuring out how to graph logs, right? So graphing logs is kind of like the last step in this introduction. Now, I already told you that logarithms and exponents or exponentials, they are opposites of each other. They're inverses. So this was a while back, but I did say that inverses are like when you graph them, they are kind of like reflections of each other, okay? In particular, they're reflections over the line y equals x, so over a diagonal line. So I would expect a graph of a log to look very much like the graph of an exponential. So I would expect it to have an asymptote, and I'd expect it to have that same shape. But let's just figure out, well, what's it going to look like by, well, my favorite method of plotting, just by plotting points, okay?
That would be really hard to translate over y equals x because it's curved.
Yeah, I think I wouldn't do it myself. Honestly, even like simple graphs, I wouldn't want to reflect over that line. So that's why we're just going to plot some points. Okay, so let's just start plotting. I think the easiest point to plot is x equals 0, right? That's always a good one to start with. And if I'm plotting x equals 0, I'm trying to figure out what log base 2 of 0 is, right? Now, does anyone remember what the log anything of 0 is? 1, right? So that was one of our log properties that we learned about. It's always going to be 1. If we're finding the log of 0, it's always 1, okay? 2 to the
base subscript is
no, this isn't right. This isn't right. I made a mistake. Oh my goodness, this is so embarrassing. This is wrong. Oh my god, I didn't even do that on purpose. I feel so bad. I usually try to make mistakes on purpose, and oh my goodness, I did it wrong. Okay. Well, let's try to figure out what this is then. Okay, so did we all erase 1? Is it all erased? Okay. Oh my goodness, I cannot believe this.
2 to the what is 0.
Yep. So if I were to write this in exponential form, this would be 2 to the question mark equals 0. What power of 2 equals 0? Well, 2 to the 0 power is 1, right? So it can't be 0. 2 to the 1/2 would be the square root of 2. This is actually a trick question.
Is it not undefined?
Undefined. There is no power of 2 that will give you 0. Okay, and I mean, it's a trick question. I even fell for it. I can't believe I fell for my own trick there. Oh my goodness. Okay, this is undefined. Okay, there is no power of 2 that will give you 0. You can raise it to as many powers as you want. You're not going to get 0 as an answer. Okay, now when something's undefined, how do we draw it? You don't draw it. Okay. What else do we draw? Starts with an A. Asymptote, right? So at x equals 0, we're going to have a vertical asymptote because, well, our graph, it's undefined, right? Yeah, can't touch it. I am very sorry about that. It must be the turkey. Oh my goodness. Okay. Let's do an easier one. Let's do x equals 1. Okay, when x equals 1, yes, we're doing log base 2 of 1, and that is 0 because there is a literal property of logarithms that say log of 1 is always going to be 0. It doesn't matter what the base is. The answer is 0. Okay, so I have a point at 1, 0. Cool. That was pretty easy. Let's do x equals 2. Let's try that.
It would be one.
Log base 2 of 2.
Anything, the base and final answer are the same. It's going to be one.
Yeah, that actually is one of the row properties, right? Also, 2 to the first power is 2. So looks like we have a point at 2 comma 1. Okay. I'm even going to go further. I'm not going to do 3 because that's not going to give us a good number. Let's do 4. Okay. Log base 2 of 4. Okay. What's that going to be? 2, right? Because 2 to the second power is 4. Okay. So we have a point at 4 comma 2. Okay.
It makes me think it's weird because the final answer.
Yeah, it's just a weird way to think of it. Honestly, I'm not the biggest fan of logs either. Okay.
Yeah.
At this point, I know that this is going to look like the exponential form. I know it has an asymptote, and I know it kind of like curves upward. So I'm actually not going to plot any more points because I know that my graph is going to kind of look like this, right? And I know that as I get closer and closer to the asymptote, my graph is going to get closer and closer to the asymptote as well. Okay. So once I have those points plotted, there's really nothing else I can do. I just have to get closer to the asymptote and go upward, and I have my shape.
Well, what happens if you try f equals
Yeah, let's try that. Let's try -1. Log base 2 of -1. Okay. Well, that's the same thing as asking myself, 2 to the what power equals -1?
Right.
Is there any power of 2 that gives me -1? No, right? So this is also undefined.
So anything negative would be undefined.
Yeah, everything negative is undefined. So there's actually nothing on the left-hand side of that graph. Crazy, isn't it? Kind of like exponentials, right? There's no exponents that give you a negative number. Yeah. All right. Now, it would be kind of mean for me to ask you to do example 8 on your own because it's a little bit different. I think it's slightly harder. So let's go ahead and do example 8 together so we are all on the same page here. This time, the base is 1/4. Remember, with exponentials, when we had a fraction as our base, it looked different, right? It looked like exponential decay. So I would expect my log graph to look a little bit different than example 7, right? Okay, let's start plotting some points. Let's do x equals 0. Okay, this is log 1/4 of 0. What is the log anything of 0? Undefined. Good. At least I got it this time. Undefined, which means we're going to have our vertical asymptote at x equals 0. Same thing as the last one. Okay. Let's plug in x equals 1. Let's do the log 1/4 of 1. What's the log anything of 1? 0, right? That's one of our properties. If we're taking the log of 1, it's always going to be 0. So it looks like we have 1 comma 0 as one of our points. Okay.
Wait, yeah.
I'm actually going to skip 2 because it might be a little hard to figure out what log 1/4 of 2 is. Might even be hard to find 3. Let's try 4. Let's try that. Okay. So let's do the log 1/4 of 4. Okay. Now, if I want to figure this out, it might be good to put this in exponential form just so we can think about what's going on here, right? What's the base of my exponent? 1/4. What's the exponent of my exponential? Question mark. And the final answer is 4. Okay. What power of 1/4 gives me 4? Not 4. Not -2, but -1, right? When we have a negative power, we flip the line, right? And we're not like squaring or anything because it's still 4. So this is actually -1. Okay, so 4 comma -1 is one of my points.
Can you step by step do that again?
Yeah. So basically, like you could do 1/4 to the first power, 1/4 squared, and 1/4 cubed, and you're just not going to get this, right? Now we can try negative values, right? So this is 1/4 to -1. Yeah, it'd be 4/1, right?
4/1 to the first.
Yeah.
So
and if you wanted to do 1/4 squared, it'd be 16, right?
Right.
And then cubed would be whatever 4 cubed. Yeah. Oh yeah, -2. Oop, here we go.
Okay. because we're trying to find power. That's what it's.
Yeah. Yep. Okay, we could go on going further, but I actually want to let's do an easy one. Let's do 1/4. Because let's see what happens when we're doing log 1/4 of 1/4. What happens when the bases are the same as the inside of the log? Just one. So I have 1/4 comma 1 as one of my points. Kind of hard to draw on my graph, but I'll just draw it over here. Okay. I got 3 points. This is pretty much all I need to draw my shape. I know that it's going to look like the exponential, like turn on its side a little bit. So, oh, that's bad. We're going to try to draw it like this. And as I get closer and closer to the x-axis, I'm going to get closer and closer to it, but I'm not going to touch it. Okay. So it looks a little bit different, but it's kind of flipped over. It's like example 7, but flipped. Okay. Any questions on graphing logs?
Okay. There was something in pre-calc, very vague remember. But when we graph things in pre-calc with like logarithms, it almost looks like x cubed. Not sure if that's right.
You might be thinking of
it was like the x cubed, but it was kept like going across the graph.
You're probably thinking of the cubic function, which looks like that.
No. It was vertical. It was the normal x cubed, except it kept going.
Oh, like that?
Yeah.
That's tangent.
Oh.
Yeah. Okay. So we're not going there. We are not going there in this class. Yeah. Ooh, no way. Okay. Yeah, we're not going to trig here. That would be very sad. You would not like that. But just to recap with logs, logarithms will always have the vertical asymptote, right? So if you're drawing a log, draw that vertical asymptote at the x-axis, okay? Depending on if you have a fraction or not, it's either going to go this way or the other way. But you're always going to have that 1, 0 point, right? That no matter what the base is, that's always going to be there. The exponent kind of depends. So if you have 2 as your base, you're going to have a point at 2. If 3 was your base, the point would be at 3, 4, 5, so on. Okay. So honestly, to me, I would at least start with the asymptote 1, 0, and then you can kind of plot points based on like your x and y chart. And once you plot a couple, then you can just finish up your graph. All right. Any other questions on graphing?
Are we ever going to have to translate these?
I'm not going to ask you to translate them. I might ask you to draw it on a test, but I'm not going to ask you. I might ask you to draw the graphs.
Right.
Yeah, I don't think I'm going to ask you to translate just because there's so much variation in the base. I'm not going to ask you to.
I don't know how that would actually work. Like, would it work the same?
Yeah, it would work the same. It would work the same. It just.
So like if it was like log 1/2 x plus 2.
Yeah, you would just shift it up. Yeah.
Mm-hmm.
All right.
How would you do that to make it shift to the left or right?
You would just put it inside the log. So it'd be like log x minus 2.
Oh, okay.
Right? Yeah. All right. I think we should start a new set of guided notes. Okay. So we're still going to talk about logarithms, but sometimes we have to combine logarithms together. Sometimes we want to rewrite them as different logs. And these properties actually help us be able to solve logs a little bit easier. And they come in handy when we're solving equations, all that fun stuff. Okay, so in logarithms, I know we talked about a few properties of logs, like how the log of 1 is going to be 0 no matter what, but there are actually other types of properties, in particular 3 that are very important that, well, we'll cover in this section, okay? I'm going to go over the 3 of them separately, okay? And I think each of these 3 properties aren't hard in of themselves, but it gets kind of hard when you combine them all together. And we'll talk about that after we go over each of them individually. So the first property that I want to talk about, it's called the product property of logarithms. Actually, I've never heard of it being called the product property, but the textbook calls it that, so there we go. Up here, I just have a bunch of stuff. You really don't need to know this part of the definition. It just says that these guys are variables. But let's just say I see a log, and inside the log, there is a product or multiplication going on. So x times y inside. what we can do is we can actually break this up into two separate logarithms and add them together, okay? So basically how I'd say this is if I take the logarithm of multiplication, it turns into addition on the outside. Multiplication inside, addition on the outside. I think it's easiest to just look at it through an example. So let's just take a look at example 1a, okay? If we take a look at this log, I have multiplication on the inside. Since two things are being multiplied on the inside, I can split this up into two logarithms, log base 2 of 8, log base 2 of x, okay? And add them together. Okay, so the multiplication on the inside turned to addition on the outside. Does that kind of make sense? Okay. Now, I'm actually not done this problem because I can actually simplify something over here. I have log base 2 of 8. Is there a way I can write that as just a number? What number is it? Yeah, 2 to the third power equals 8. So this guy is actually just 3. Okay, 3 plus log base 2 of x. Okay, so I expanded out the log. I even simplified one of the logs. This would be a final answer for me. Okay, now sometimes you'll split up a logarithm and you'll realize that like if you get something like this, you won't get a whole number. If this turns into a whole number, I'll have you simplify it. If this turns into a crazy decimal or something, we're not going to simplify it. We would just leave it like this. And we'll see that in the next one. Yeah, like ln of 5. Okay, let's keep going. We have ln 5xy. This time we don't just have two things being multiplied on the inside. How do you think we should split this up? So what do you think is going to happen when there's three things being multiplied? Yep. Just Yep, I'll take ln 5, ln x, ln y, and just add them together. Okay, so whenever there's anything being multiplied on the inside, we can split it up into things being multiplied or added on the outside, right? Now this time, ln of 5, you can try that in your calculator. It's going to give you like a really big decimal, right? We can't do that. There's no power of e that gives you 5, so I'm just going to leave it like this. This would be my final answer if I were to say this on a test or quiz or something like that. Okay.
Is there any ln to anything visible
E.
given what's for e?
One. Yeah, 1 e squared e to the fourth. That's about it. Yeah. If it's just a whole number except for 1, yeah, I would just leave it.
So ln of e to the second is 2, right?
Mm-hmm. Yep. All right, our last one. We have log base 3 of x times log base 3 of y. Now, this is something I add because a lot of people will see this and be like, oh, well, I guess there's multiplication on the outside. That becomes addition on the inside, right? So a lot of people would see this and be like, oh, this is log base 3 of x plus y. Okay, that is not okay. That is not what the rule says, right? The rule says that if you see multiplication on the inside, it turns to addition on the outside. No. So even saying this, log base 3 of xy, this isn't the same either because this means to split it up into addition on the outside, right? So those two things aren't the same either. This is actually something that can't be expanded or simplified. You can't do anything here, okay? I think the textbook throws a couple in like their practice exercises like this. There's nothing you can do. It's a trick question. The only thing you can do is multiplication on the inside, addition on the outside. It's the only thing that can happen. Okay. Any questions on?
That would be log base 3 square xy.
Oh no, so you can't do anything to the bases either. So you can't be like this is yeah, so this wouldn't be log 9xy. There's really nothing you can do here. Yeah. All right. Let's go to the second property. This is the quotient property of logarithms. Kind of self-explanatory. We said that multiplication on the inside is addition on the outside. Division on the inside is subtraction on the outside. Okay, so it's kind of just like, well, multiplication and addition kind of go together. Division and subtraction go together as well. Okay. Let's do log base 3 of C over D. Okay. How would I split this up? Log base 3 of C minus. Perfect. Okay. Now it is very important that the number on top goes first. Okay. So it would not be okay to put log 3 of D minus log 3 of C, right? The C has to go on first because it's on the top. The D has to be last because it's on the bottom. Okay. With subtraction, it's not a commutative property, so you can't flip them around. Okay. I'm going to give you like 30 seconds to try part B. I will say that there is something that you can simplify after you expand. So you can get a real whole number out of this if you really want to. And we'll come back in like 30 seconds. Looks like we're doing good. I know I didn't give you much time for this. Did we all get, oh gosh, did we all get log x minus log 1,000? Cool. Okay. Now, thinking about this, does anyone remember what the base of log without anything on there is? Yeah, just 10, right? So this is the same thing as saying log base 10 of x minus log base 10 of 1,000, right? If it's not written, we just assume it's 10, okay? Now, what power of 10 gives me 1,000? 3, right? 10 cubed is 1,000. So instead of writing log base 10 of 1,000, I can just write 3, okay? So this really is log base 10 of x minus 3, okay? Another way you could write your answer is log x minus 3, right? Both totally correct. But yeah, fully simplified. Any questions on part B? All right, let's go to our last property of logarithms. Now, this one's called the power property of logarithms, and it deals with powers, okay? Now, let's just say we have something on the inside. So we have something to a power on the inside of the log, okay? We can actually bring this power up to the front of the log, and it becomes p log bx, okay? So whenever you see something, the entire inside of the log being raised to a power, we can take that power, bring it up front, okay? Let me show you an example of how this might apply, okay? Here we have ln. Remember, ln is log base e, okay, of the 5th root of x squared. Now, looking at this, it might not even seem like you could use that power property, right? There's no like big powers going on here. But let's just think about what this means. Does anyone remember what the 5th root is as an exponent? It's not just the 5th, 1/5, right? Instead of saying the 5th root, we can say that this is x squared to the 1/5 power, right? Same thing as saying a root, it's just in fractional power, okay? Now let's see if I can simplify this before applying the rule. Does anyone remember, like when we take a power to a power, what do we do with the powers? Multiply them together, right? This is bringing us all the way back to the first beginning of class here. But this would be x to the 2 times 1/5, which is 2/5. Okay. So what does the power rule say I could do with that 2/5? Move it to the front of the ln. So this becomes 2/5 ln of x. Okay. Yeah. Yeah. Nothing else you can do, right?
What if it was like 2/5 log? Then it would be a number.
Yeah, like yeah. Then we'd get a number. Yeah. Yeah. Be 4/5. Yeah. All right. I'm gonna give you 30 seconds to work on part B, mainly because I'm getting these Black Friday shipments on my Amazon, and I get like the little picture, and I want to see it. So while I'm doing that, work on part B for like 2 log x. That's it. The 2 just goes up front. Okay. So each of these properties are pretty easy, right? Powers just go up front. Quotient becomes subtraction. Multiplication becomes addition, right? That's pretty easy. I do think it gets kind of hard when we start putting them all together. Mainly because a lot of people get confused as to like what actually we do first. Like what order do we apply these in? And you're not gonna like the answer because it really just matters on what the question is, okay? Now, I'll kind of tell you, it's kind of hard to explain like exactly what to do first, but it kind of works just how like normal equations, simplifying expressions goes, okay? For example, let's say I see ln x squared y, okay? In this situation, I have both a power and multiplication going on, okay? But can you see that the power is only applied to the x, right? So it wouldn't make sense to apply the power rule first because the power only occurs with the x, not the entire thing. So in this case, I would want to split up the multiplication first and then split up the power. Does that kind of make sense?
Yes.
Okay. So this would turn into, well, first I would split up the multiplication, ln x squared plus ln y. And then I would move the power up front to be 2 ln x plus ln y.
So let's say it was ln x squared y squared. Would you do the power first then? Like if it's like both?
So if this was ln x squared y squared, there's two options you can do. If you leave it alone, I would still break up the multiplication first and then do the powers. But this is the same thing as ln xy squared, right? So then if it's applied to the entire thing inside the ln, then you can apply the power first and then split up, right?
I'd probably say.
Yeah, I just split it up and do the power. Yeah. On the other hand, let me just do another one. A lot of people will see stuff like ln xy over z. Okay, and people are like, okay, there's division, there's multiplication. Which one do I do first? Any guesses on which one would go first?
I do subtraction first.
I do subtraction first. Okay, and the reason is because the multiplication is only between the x and the y. It's not the entire thing, right? What's really happening in this is we have something big divided by another something big, right? So I can't split up the multiplication until I get the multiplication on its own, if that makes sense. Okay. So since the entire thing is really just this big division sign, I would split up the division first, ln xy minus ln z, and then I would split up the xy. Okay. So we'll just do some examples. I just wanted to put those basic examples or run them by you first. Let's do example 4a, okay? So I have log base 2 of z cubed over xy to the fifth. There is a combination of everything here, right? I have a power, I have division, I have multiplication. Which one am I going to undo first? The division, right? Because inside this logarithm, I have a big division sign, right? That is the biggest thing going on. I can't split up the multiplication yet because it's only between the x and the y. I can't do the power rule because they're only applied to the z and the y. So I have to split up the division first. So let's go ahead and do that. This becomes log base 2 of z cubed minus log base 2 of xy to the fifth. Okay. So any questions on what I did just here? Cool. Okay. Couple things I can do here. Any ideas on what we could do next?
Well, for the log base 2, said 2
Yeah, let's do that. Let's just do the one step where we bring the 3 up to the front because there's nothing else going on in that first term. This becomes 3 log base 2 of z. Okay. And I'll just trail along the log base 2 of xy to the fifth. Okay. Now I'm pretty confident I did everything I could do with that first term. There's nothing else I can do there. Let's focus on the second term and see what we can do, okay? Now, remember, this 5 is only attached to the y, right? So we can't do anything with the 5 yet because we haven't gotten the y by itself yet. So what are we splitting up first? The x and the y, right? Multiplication turns into addition. I'm going to write something down. It's going to be a little bit wrong. Okay, 3 log base 2 of z minus log base 2 of x plus log base 2 of y to the fifth power. Okay, So I took this addition, or I took this multiplication, I turned it into addition. What did I do wrong? Parentheses, right? I'm subtracting off. This minus sign is subtracting off this entire term. This entire term becomes this entire phrase. So I need to subtract off the entire phrase because that's what this was, right? So I need to put parentheses around this entire phrase here. If I don't put parentheses here, this plus actually isn't correct, okay? Now I have parentheses, that plus mark is correct. Any questions on the parentheses there? Cool. Okay. A couple options for me. Any ideas on what I can do next? Yeah, let's do that. Yeah, let's move the 5 up front. Yeah, let's keep everything in parentheses, keep everything the same, except we're going to move that 5 up front. Log base 2x plus 5 log base 2y. Okay. What's my last step I could do? Yeah, right. So basically distribute the negative, right? Or change the signs, right? This becomes 3 log base 2 of z minus log base 2 of x minus 5 log base 2 of y. Okay, and that would be my final answer. Okay. Any questions on what I just did for part A? Okay, I think this was kind of hard. I promise you it gets a little bit easier with some practice. There's something like this exactly on your homework, I think. But talking about practice, why don't we try part B? Okay, part B is going to be a little bit easier, okay? I'll kind of explain why later, but I want to give you a crack at trying part B. I feel like I didn't give you enough time, but in the interest of time, I think we should just start now because I don't want to have you stay later than 12:50. All right. So I think as I walked around, I saw everyone undo the division first, right? Cool. So this became ln a to the 4th b minus ln c to the 9th, right? Everyone had this, right? Okay. Any ideas on what I can do first? Yeah, good. Is that what you're going to do, Evan, too? Yeah, good. That 9 goes up front, right? That's a pretty easy property to apply. Let's go ahead and do that. ln a 4th b minus 9 ln of c. Cool. Now, this one's pretty much done. There's nothing else I can do here. Here, I have a couple things going on. I have a product and I have a power, right? Now, remember, this power is only attached to the A. So I don't want to apply the power rule yet because if I bring that 4 up front, that 4 is only in front of the A, not both the A and the B. So, I mean, I guess I just told you this, but I guess we're splitting up the multiplication first, right? Okay. So this becomes ln a to the 4th plus ln b minus 9 ln c. Now, at this step, I didn't put parentheses around my expansion, okay? I did it over here, right? Over here, I had to put parentheses around this. I didn't put parentheses around here. Why did I put parentheses around those two terms in this example? Yeah, it's the first term, and there's nothing being done to this guy here, right? There's no negative up front. There's nothing multiplied by it. So I don't need to put this in parentheses. Up here, I did need to put this in parentheses because there was a minus up front, right? So if there's a minus in front of what you're expanding out, you better put that in parentheses or else, well, you're going to miss a minus sign somewhere, okay? Here, I don't need it, right? Okay. Anything else I can do to simplify this? Bring up 4 to the front, right? This becomes 4 ln of A plus ln of B. Ooh, that looks ugly. Ln of B minus 9 ln of C. And that would be my final answer. Okay. Any questions on example 4?